Hi, guys. Sorry I'm not there today, but I will be there tomorrow. We're going to do our second lesson in Unit 2. This time we're going to talk about another part of the circle called the arc of a circle. So yesterday we talked about a chord. Remember, a chord was just like a line segment inside the circle. And so today we're going to add to that. And then tomorrow we'll have another lesson where we kind of connect how arcs and chords are related to each other. So I'm going to turn on my hover cam so we can do some notes. So if you could have out your notebook, something to write with, you may also need your calculator. This lesson just has a little bit of adding and subtracting, mainly subtracting, nothing crazy. Then when we're done with this, you'll have an assignment. I can post it on the Google Classroom, but I do have it printed so you can do it on paper. At any point, you can pause this video if you need more time to take some notes down. I might also give an example and ask you to try it. So that might be a good place to pause and try and then play it to check your work. I think I have figured out how to make the sound better. So hopefully you're hearing me better, but we shouldn't have to do this much longer. So I'm going to turn this on and get us started. Okay, I'm going to get my piece of paper for our notes. All right, so this lesson is 212 arcs of a circle. So if you remember, I said chapter 2 is all about circles. So far, we have talked about parts of a circle. So if we have a circle, oh, it wasn't too bad. Remember, we have a center. That's our center. Remember, we've also talked about how a circle has a radius, and the radius is always from the center to a point on the circle. We have talked about a circle having a diameter. So remember, diameter is like two radii together, goes all the way across. That's our diameter. We have also talked about a circle having a chord. And if you remember, a chord has two endpoints on the circle, like that. That was, remember, our chord. And then we've also talked about the distance around the circle. So if we went all the way around the circle, so the distance around, this marker's drying. Remember what the distance around the circle is called? Remember, that's our circumference. So now we're going to talk about one other part of a circle. And it's kind of related to the circumference because it is on the outer part of the circle. It's not anything inside. So we're going to talk about the arc. And what the arc is, it's part of the circumference of a circle. So I'll draw a picture of that. So if you have your circle, ooh, that one was pretty good. We're centered. And let's say we have point A on our circle and point B on our circle. So from here to here is an arc. It's part of the circumference of the circle. So it's not all the way around. It's from here to here on the circle. So that right there is an arc. Oops, I almost spelled arc wrong. Arc. And the way we write it, so anytime we kind of name things, we have a special notation. The notation is kind of how you write things. So it's written with the endpoints, but with like a little arch above it. And so that's how we would name this. So this would be arc AB with a little thing, as it goes from A to B. And if you're reading that, so if it's read arc AB. So if you had this like in an assignment and you see this, you can read that arc AB. So that's what they're referring to. The distance from one point to another on the circle. It's not all the way around. And what this really means when you see this, that this means it's the arc with endpoints A and B. So what we're going to do today is we're going to kind of learn how these arcs, these part of the circles, are related to the bigger part of the circle, how it's related to angles inside the circle. As we go further into this chapter, we'll also learn how to figure out the measurement of that. So today we're just going to talk about it in degrees, because if you remember, a circle is 360 degrees. But later in the chapter, we're going to talk about like the actual length in terms of units. Degrees and units kind of are different. And so we might talk about degrees, but if we're actually saying the distance around the circle, that would be a unit of length, and degrees are not really a unit of length. The degrees are kind of telling you like the proportion of which this takes up of your full circle, but not the actual length of the arc. But we'll get more into that later. So, we talk about, so remember radii is when you have more than one radius. So let's talk about how the radii and the arcs are connected. So if you have a circle, center, and we have two radii marked. So say we have radius here and a radius here. And remember, these lengths are always the same because every radius in a circle is the same distance. So when you have two radii like this, what happens is you get an angle formed right here. And that angle right there is referred to as a central angle. And it's called a central angle because its vertex is the center of the circle. So central angles are angles that have their vertex at the center of the circle. When you have these two radii right here and you have the central angle, there's also an arc that is formed. So if you notice, this little piece is formed by connecting the two endpoints of your radii. So I'm going to kind of discuss how the central angle relates to your arc, because what actually happens, if you can see, is here when we just had an arc and there was no angle, it's just a piece of this. But if you look here, we kind of have this, but it also, these two radii kind of separate it into this larger portion over here. So we kind of, it's like a piece here and then a bigger piece here. And so really we kind of have two arcs that are formed. So I'm going to kind of discuss what happens there. I'm going to change this paper. If you're still writing, you can pause real quick to get this all down, but I am going to remove this piece of paper. Okay, so when we have a central angle, so when a central angle intercepts two arcs, that's what we're going to look at. So I said there was two, and really if you didn't see it, I'll make it very clear. So we have our circle, we have our center, we have our two radii that are creating this central angle. I'm gonna call this A, this B, and then we're gonna have a point over here called X. We're gonna call it X. So this, remember, is our central angle. And when I say it intercepts, that means it kind of creates or creates two arcs, because these two radii form this angle. And so this angle is kind of creating two arcs, this one here and this larger one out here. And so these have two different names based on their size. So this arc right here from A to B is called a minor arc. So a minor arc lies between the sides of an angle less than 180 degrees. So you can kind of think as a minor arc as smaller. It lies between the sides of an angle less than 180. Now, if you see, we also have this big arc right here formed. And that one is called a major arc. So if you think minor is small, major is big. So the major arc is outside the central angle created by the minor arc. So this is our central angle. The major arc would be outside that central angle. So this one, the minor arc is always less than 180. A major arc is always greater than 180. Now, to help you understand if I'm talking about an arc and I'm just naming it, minor arcs are always named with 2 letters. Major arcs are named with 3 because they go a further distance. I can't just say arc AB if I'm referring to this major arc, because AB is the smaller one. So major arcs are named with 3 points. So like this one would be AXB. And the X is in the middle because you have to go through X to get to B. You could also name this arc BXA, but X would still be in the middle because you have to go through it to get to the endpoint. So if you're given an arc that has 3 letters, we know that's a major arc. It should be larger than 180 degrees. If you're given an arc with 2 letters, that should be a minor arc and less than 180 degrees. Now, what happens though if it's exactly 180? So what if this, so right now this central angle is less than 180, which means this arc is less than 180. But what happens if this central angle was 180? Because that means something too. So if the central angle is 180, that's called a semicircle. So, and if you're unsure what semicircle means, that's half a circle. And so it would be kind of like this situation. So really, like, neither of these is the minor or the major because they're equal. It's half a circle or a semicircle. So it's kind of like it's a 180-degree arc, but there's no minor or major because they're the same. And just to remind you, the circle's 360. So if this is 180, this is 180 because they add to 360. Now I've kind of been referencing like the angle measure and the arc. So if you're trying to figure out the measure of one of these, they're the same. So because this angle right here is a straight line, that's 180. That's why this arc would be 180. So when we're measuring arcs, the minor arc is always equal to the central angle. So if you're still writing this, you can pause for a moment because I'm going to switch the paper. So if you need to continue writing, go ahead and push pause and then play back when you're ready. So measuring arcs isn't too challenging as long as you know the central angle. So a minor arc is probably the easiest one if you're given the central angle, because the minor arc is always equal to the central angle. So for example, if you have a circle and you're given this central angle, so hopefully you remember what this little box tells you that that angle is. Remember that box means it's 90 degrees. So if this central angle is 90, then this arc, this minor arc A to B is also 90. So AB, arc AB would equal 90 degrees because the arc is always equal to the angle. So right here is equal to here. Now to do the major arc, the major arc is kind of like what's left over. So if this part's 90, this is the rest of the circle. So the major arc is kind of equal to 360 minus the measure of the minor arc. So if we're looking at this picture up here, to find, I'm going to put the X here, to find the measure of arc AXB, we would take 360 and we would subtract the minor arc. So we're going to subtract the 90. So arc AXB should equal 270. Okay, so that's pretty much all you have to know. Is if you know this angle, you know this arc because these are the same. If you know this angle, you can determine this arc because you just have to take this angle from 360. And then it's kind of flip-flopped. If you knew this big angle on the outside, that would be equal to the major. If you have this big angle on the outside, you just subtract it from 360 to find this one. And because like the angles match the arc, like if you know this arc, then you can find the rest of this because the total is 360. I'm going to do some examples that will be similar to what you'll see. So this one will say, what is the measure of arc AB? I'm going to draw a picture. So if you want to pause this, draw this picture and try to answer what AB equals, remember arc AB is from here to here. It's a minor arc. And this is 70 degrees if you can't read my writing. So just remember, the minor arc is equal to the central angle. If this is 70, then this right here is also 70. So hopefully you caught on to that. Let's do another example. So same directions, find the measure of arc AB, just new diagram. So in this picture, you're given this angle, not this angle. But we still are trying to find the measure of arc AB. So you're still trying to find this. So because you're given the larger angle here, to find this, we just have to do 360 minus 275. And if you do 360 minus 275, you should get 85. So the measure of AB is 85 degrees. So hopefully you're thinking, well, this isn't too bad. Let's do one more example. If you need to pause to write any of this down, go ahead. I'm going to switch this out. Okay, so last example. This one says, what is the measure of arc AXB? So let me draw that diagram. Okay, so find AXB. And if you want to pause for a minute, draw that, try it, and then push play to check your work. I'll go over that. So AXB is the major arc. So it's from here through X to here. So this outer part, we're given the central angle. So this is another one where you have to do 360 minus 75 because we're trying to find the outer, the bigger one, and we're given the smaller. Remember, these are equal. So like AB is 75 because these angles match. So we just need to do 360 minus 75. And 360 minus 75 should give us 285. So the measure of arc AXB would equal 285. So hopefully you're not finding this too challenging. Basically, they're either equal or you're going to subtract from 360. I have a worksheet for you that practices this. If you need to go back through the video and look at any of the problems, you can do that. Make sure you have good notes so you can identify what you're finding. If you finish your assignment and have extra time, I recommend that you go back and see if you have any missing work. Grades are put in. I did put in some quiz grades, but if you were absent, I put absent in there so it didn't count against you. But make sure that you check your grade. If you have anything missing, work on that. And then if you have everything done, maybe work on Apex for another class. I will be back tomorrow and we'll do more with circles. But I hope to see you soon. And if you have any questions, go ahead and contact me. Have a good day.